So could you tell me about your time at Rajaram College and later at the Institute of Science in Bombay? What were the key subjects that captured your interest? Now you are at a place where you have possibly physics as the main subject. What was the degrees you pursued there and subjects that you
Okay.
studied?
So in those days, there were after high school. So it was slightly different system than it is now. After high school, one had 2 years of college, and after the
Hmm.
first year of college, you could go to IIT because IIT was a 5 year program basically. Or you went to a second year, and it was called intermediate science. And then if you're in the science track, arts track was completely different. I'm just talking about science track. So in your
Hmm.
second year, you had to specialize between either you opted for physical sciences or biological sciences. So physical sciences were in those days physics and chemistry and mathematics, and biological
Hmm.
sciences were botany and zoology and chemistry. And so chemistry is common to both of them. And so it was called Group A and Group B. And so I was interested in the physical sciences, not biological sciences. But somehow people used to tease me, my dear friends in college, that every year
Okay.
I always dropped the subject that I was best in. I mean, best in terms of grades, in terms of marks, or whatever it is, right? So the
Okay.
first year I was first in all of state for in the civics and administration. I dropped that. Then I uh, was best in chemistry, and so in the second year I dropped that, and so I went into then uh, into physics and mathematics, and then later on I was better in mathematics, but I dropped that. I kept in physics. So it's basically again this inner interest versus yeah. Okay.
Hmm.
Now coming back to professors, and as I was mentioned before, the, none of them did actual research, but they were very good teachers. Not all of them, but among them there are some very good teachers. There were some who were really parrots. In other words, they had learned their spiel once and for all, and every year they repeated the same thing, and you could tell that they didn't really understand what they were saying. I mean, in the sense that they understood the literal word of it. For example, I would go in their staff room and ask them questions. So there was one professor who was
Hmm.
very popular because he was very systematic, and everything in blackboard was neat, and year after year it was
Mhm.
exactly the same thing. He used to teach optics,
Mhm.
and I would ask him some, how to solve some very simple optics problems about refraction and such thing, and he had no idea about how to solve the problem. So I really didn't understand the subject. So there were people like that, but there were also people who really
Hmm.
understood it. So in physics, I had Professor Dravid. He understood things very, very well, and he was very kind to me. He took me in his folds, if you like, and I would go to his house even and borrow his
Okay.
books from his house and discuss things with him in his house. The same thing was true with my professor in chemistry. He was Professor Vaidya.
Hmm.
He encouraged me, for
Hmm.
example, in those days to, I was 17 at that time. It was not usual for people to know anything about quantum mechanics at all. In fact, none of my contemporary students knew anything. And so, he encouraged me to sort of
Yeah.
read about old quantum mechanics, not new quantum mechanics, but, Bohr atom and such thing. And I remember I
Hmm.
learned about Bohr atom, and then they would even invite me to give a talk to the students, to the whole class on
Oh,
whatever
okay.
whatever I learned. So that was, good for
Hmm.
me to, because it also forced me to really, it's when you try to explain something to somebody, then you understand it well. I
That's
kept
true.
telling it to my students all the time. So in that way, they were very good. Right? These professors were extremely good. And similarly, there was a professor of mathematics by name Joe. He was also extremely good, and he's the one who encouraged me to. I mean, he thought he was the only one who thought it was natural that I turned down IIT, and I went to
Hmm.
and as a luck would have it, he was transferred to the Institute of Science, or Royal Institute of Science in Bombay, that I went to, because it was also a government college. And
Hmm.
then I went in, and again I met him in the Institute of Science there. So I had these very good professors, and they somehow saw that it was worth investing in me in some ways. Another professor of mathematics by name Murdeshwar would give us some very elementary problems in set theory. which you had to solve.
Mhm.
So it was very good, and I was very proud when I could actually solve it in the class itself, right? And I remember that day, very happy
Mhm.
about learning something
Mhm.
interesting. And then we had the whole principal of the whole college. He was not in sciences, but because
Mhm.
Rajaram College had both arts and sciences, so it was. But he also took interest in me, and in those days, a student could not take books outside the library at all. And so he
Yeah.
actually gave me his car so that I could actually take books and several books out of the library for reading. And I remember people being
Oh,
shocked that he actually just gave me his car. You know,
yeah. It is.
so what I'm trying to say is that these people were extremely, extremely nice and extremely helpful, and they were excellent mentors who really encouraged me, and I'm most grateful to them all the time because it's in those early days that you need much more mentorship in some ways.
Did you have any professor or a teacher like your go-to teacher when you are solving a problem, you're not able to figure out how to tackle this, how to strategize and
Yeah, so in
solve this?
Rajaram College, I
Oh,
mentioned to you these three people. I mean, Professor Dravid for physics, Professor Vaidya for chemistry. Yeah, they were always right. But in India, we say, "Well, I have some difficulty." Right? Instead of, I'm stuck somewhere. So I have some
mm.
difficulties, and then you go to them, and they solve. And they were always very kind.
When you received the National Science Talent Scholarship that enabled, weekly TIFR visits, I believe. Could you tell us about that? Based on my basic research, I do understand that it also had a big
Right.
impact.
So I have to tell you because there's a very nice positive side that we'll spend some time on, but there's also something that I would like to mention about negative side on Indian bureaucratic thing that I think that it still persists, and I feel it is good to be recorded so that maybe somebody
Mm.
listens to it and does something to it or something like that. So what happened is the following. So at my in those days, I did my high school. I was 16, and I got this national scholarship. Next
Mm.
year, they announced national talent for sciences, right? But national scholarship in those days was considered to be most prestigious, and national talent wasn't so good. So I saw no reason to apply or to appear for an exam for national talent because I already had national scholarship, which was much more uh, prestigious and much better. But then the next year, that is when I was 18, right? They national talent scholarship. They wanted to attract more people to science, so they suddenly changed their scope and they said that there will be summer schools and the stipend will also be higher, and if you stayed and did masters it will continue in the masters provided your progress was satisfactory, etc., etc. So suddenly then it became better than the national scholarship, which until then was the epitome of everything. So
Mm.
I decided that I would like to apply and to compete for this, right? So I wrote a big letters,
Mm.
saying that, well, I would like to compete. I didn't do it last time because of this reason, etc. So they said, okay, go ahead, go ahead and compete. So I competed and I got in. I got the scholarship and everything. But ultimately, when I went to Institute of Science, they said, no, you will not get the stipend, and you cannot go to the summer schools. You can keep the title,
Oh.
National Talent Something. And this is because of some bureaucratic administrative reason. But when the TIFR people took some interest, and when I mentioned to them what had happened, then Professor Yashpal,
Mhm.
who was one of the mentors in TIFR, and he then became a very influential person. He was the head of UGC, and he's the one who, for example, went to Supreme Court against some universities in Madhya Pradesh, which were being uh, propped up by politicians, and he won against these politicians, which is pretty amazing. So Yashpal actually said, "Okay, I'm going to Delhi. Give me all the details." So I wrote it all down. He went to them, and they said, "No, we can't do anything." So this is the kind of thing that should not happen.
Mm.
Now, I usually used to not go into these details because yeah, the bureaucratic thing, and who cares about this slight injustice, something. But nowadays, I'm doing it because this is continuing to happen, and currently we
Yeah.
have a
Mhm.
postdoc
Mhm.
who
Mhm.
from India. That's not my postdoc, but is in the he works in gravitational waves, which is a frontier field,
Okay.
and he,
Mhm.
as a PhD student, he also appeared for one
Mhm.
of these exams, which was conducted by
Mhm.
CSIR, and you won this very prestigious scholarship, which is called Shyam Prasad Mukherjee Fellowship,
Prasad
and
Mukherjee,
that is
yeah,
supposed to be
Shyama Prasad.
cover your PhD years completely. So
Yes,
he,
yes,
he then
absolutely.
went to this Inter-University Center for Astronomy and Astrophysics, IUCA, in Pune, which was started by
I,
Professor Narlikar. I had a lot to do with
mm,
that center, so sometime we'll talk about that also, how it came into existence and many
mm,
first years of the center. Um, so he went there for this postdoc, and then again for some bureaucratic, he got this scholarship. He has his letter or something, but apparently IUCA
mm-hmm.
administration didn't send them some letter certifying attendance or something. And for that reason, they
Oh,
refused to pay him. And so he completed his
oh,
4-year
that is,
PhD with no money. And
oh,
so he went into debt. So these things are still happening. And I would like this to be recorded because I would like to both, hopefully, some responsible person comes to realize that
yeah,
these are talented young people. And in their career, if early on this happens, they are completely. So, and the second thing is that I just wanted the younger people also to be aware of being careful about
yeah,
bureaucratic things, because I was not very careful when I was myself young. So I think that's a standard limitation. I happen to be lucky
mm,
and I somehow managed to survive, but other people who are not careful. Okay. So with this, I got this
mm,
National Science Talent Scholarship, and then I went to Institute of Science. And then again, I consider myself to be extremely fortunate in many, many ways, and being, first of all, fortunate for good timing, but also fortunate to meet people that I met at the time. And then there were these two people, very senior scientists in the TIFR, Professor B.S. Udgaonkar and Professor Yashpal. And they thought that it would be good to try to get younger people interested in science. And so they basically invited people who had National Talents, Science Talent Scholarship to visit to
mm,
TIFR once a week. And we could, from the Institute of Science, actually, we could take a bus not very far from there and then go to TIFR, and they would meet us. And the one of their then PhD students, Ramnath Kaushik, who is a very distinguished scientist, is in St. Louis,
mm-hmm,
and he's been director of the institute for the longest time, and he's a cosmic ray physicist. So he would come, and
mm-hmm,
we would, you know, they would ask us questions, and we would ask them questions. And at one stage, we decided to go through Feynman lectures in physics. And in those days, Feynman, these volumes of Feynman's had just come out, which were hot in those days, and that learning physics in this new way
mm,
of something, Feynman's way and such thing. And so we were going through that, and I also thanks again to Gamo's book. And then I learned a little bit of
mm,
cosmology in the middle, picked up in the by myself. So I started thinking that, well, Gamo had a little qualitative exposure about how the universe was very hot in the beginning and how it cooled down, and what the early universe cosmic history was, and so on. And
mm-hmm,
I kind of felt that, well, I mean, that in those days people were thinking about, well, what happens if fundamental constants are not really constants, but they are slowly varying in time.
mm,
So I tried
mm,
to write something up saying that maybe the gravitational constant is really not a constant, but it's slowly varying in time. Then, if it is varying in time, how
okay,
would it vary? So, by dimensional analysis, I related it to fundamental property of the universe, and I said, well, it really depends on that property of the universe, and from there, try to see how, if this was actually the case, if gravitational constant was changing in time, cosmic history would be different from each
mm,
other. These were very babyish things. I mean, they were not, publishable. But I still, again, had confidence in myself, so I wrote it down. Professor Yashpal and Professor Udgaonkar suggested that I talk to Professor S.M. Chitre. I went and gave him this couple of sheets of paper handwritten about it, and he actually went through it, which is amazing. He gave back very positive feedback and encouraged me very much. So that again built up confidence very much. I mean, there's no question about it. And then this Feynman lectures are not very
yeah,
important. So Feynman's lectures, in particular,
mm,
there were a whole bunch of problems in Feynman lectures in physics, and the answers were given, not the solution of the problem, but just the final answer. They were just given listed
mm,
at the end of the book. And we were asked to go through some problems. So I went to this problem and I got an answer which was same as in the book, and I said I was happy. But then later I realized, I mean, that night, that there was a conceptual mistake I had made. And so next day I corrected this conceptual mistake and I got a different answer. It was different.
mm,
The functional form was the same, but the numerical coefficient was changed because of this difference. These are important things because sometimes numerical coefficient can change, seems small, but it can be fundamental mistake. And so
mm,
again, having this confidence in oneself and having the like just the same spirit that did not hesitate me from knocking on the door of Professor Chitre and giving him this sheet of paper, which which was pretty audacious in some ways, impinging on his time. So similarly, I decided to write a letter to Feynman, and I told him what happened. That
mm,
the first I got this answer, the second then I did it again, and then I got this, and I think this is the correct answer. What is in the book is not right. And to my
mm,
great surprise and incredible pleasure and honor, Feynman actually replied saying that the book was wrong. You're right. But then, he also concluded by saying, "You understand the subject well enough to rely on yourself." I think indicating that I shouldn't keep writing to him. So, for other similar issues somehow. But to me, that was a big boost in the inner confidence. This is what I was
yes,
saying before, that you may have inner confidence to do those things, but if there is an external validation that comes from some objective means, and of course there could be
mm,
no further objective means than a letter from Feynman in those days, and so I felt that that was really very helpful.
right,
Okay, so and that this letter from Feynman and the evaluation of what a little thing that I had done by Chitre was very, very helpful for me when I applied to PhD
mm,
programs later on. I was incredibly lucky. It could have happened that, Professor Yashpal and Udgaonkar had not decided to do it that year, and then I would not have met any of these
mm,
people, and nothing of these things will happen. So I want to tell younger people that, believe in yourself
mm,
and make use of every opportunity you get. That's important also, not just believing yourself, but to make and working very hard. During these
mm,
years, I was experimenting with life in many ways, right? I mean, like, for example, I took leadership roles in student unions and student activities. Process of finding oneself. In retrospect, I feel that that was a mistake. It was a waste of time in some ways for me. But it was a process of finding yourself as to what you can do, what you cannot do, etc., etc. But I also found, and this is another thing for younger people, already in my second year of college, and also my final 2 years of BSc, because I was interested in this other thing like reading Feynman lectures, thinking about cosmology, trying to understand general relativity. I used to go and in the library and try to read Hoyle-Narlikar theory, for example, because in the Institute of Science library there are proceedings of the Royal Society. So, it's not that I understood very much, I should say, but I just got some global idea, global feeling, because unless you can do calculations, you haven't understood things. But it gave me some general feeling which about how research is done or whatever it is that are useful. But of course, there's conservation of time. No matter who you are, there are only 24 hours in a day. So if you give this time to
that's
this, then of
absolutely,
course you're not giving the same time to your curriculum, my
mm,
usual
mm,
coursework and something, which I frankly found was boring. But nonetheless, I did. And so in the exams and so on, it's not that I did badly by any means, but I did not do as well as I had done in the very first year, the first beginning of my end of my high school and beginning of my college years. In the subsequent years and college years, I did not do as well because I had widened my interest in fundamental things. And I just wanted to say that not to get disheartened to younger people if this happens, that it may be, I mean, you still have to do very well, right? You still have to be among the best people, but maybe you're not the best and
yeah,
should not be. Don't take, I mean, I took it to my heart. I was very depressed by the fact that I was no longer the best or something in my class or my university. That I don't think people should do because there's only 24 hours in a day. You cannot do everything. So if you are going to pursue these fundamental things which are not in the syllabus, well, then your exams are not going to be
yeah. You may not do well
as
in the
well, right?
exams
And as
because
you would have if you had given all your time to that or more time to that at least. So
yeah.
but it should not get discouraged.
It's very important, the gesture that Feynman replied to your query. I think it's very important that prominent scientists and experienced researchers who whom youngsters they look in terms of inspiration. They are their role models. Such gesture would really inspire young students to pursue further, as it provided a boost to you. I think the same way it is important, and I think great people really do that. But I think, yeah, it's very important that everybody does that
Yeah,
in
no,
that way
I
actually.
completely agree with you. I mean, I get again, but there's only 24 hours in the day, and so you cannot do everything you want to do.
Yeah.
I get, I'm always way behind my emails and such things. I get, I don't know, about one letter a week from some young person like that. It can be from Spain, it can be from Africa sometimes, northern Africa, many times from India, of course, sometimes China. And I make a point to reply to them. Not absolutely every time, but almost every time. I mean, I make a point to
Yeah.
reply to them. I often don't reply to the older people because I mean, people sort of say that, well, I'm a, I don't know, computer scientist, and I have this idea about how the universe was born, etc. And then there's a long paper, and I mean, just 24 hours in a day. I mean, you may have the best intentions, but there's just not enough time.
It's,
But I give a priority. Younger they are, I mean, if they are high school, the end of high school or beginning of undergraduates, I actually give a priority, and I try to reply to them.
okay. During your time at the institute, by what time did you decide that you want to pursue this further, or was it already in your mind that you are going
Yeah,
to pursue
when I went to the
PhD?
institute, I already felt that I should pursue this. I mean, what pursue means was not clear. I mean, could I be that I just got my uh, PhD in the institute itself, and then went and taught in some college or something, or it could have been. But that I would to pursue this was considered, yeah, something that I had already made up my mind. I had to unfortunately say that in the Institute of Science, I did not find any inspiring teacher. They were not bad
Oh.
teachers, but they were not good teachers either. And they were just repeating what is in the books and things like that, and they were not, which was a big surprise because I would have expected a qualitatively better than Rajaram College. Rajaram College, at least, even if they didn't do research, as I mentioned before, they encouraged and they did things. Whereas here, I mean, it could just be Bombay is a big city and life takes whole in the sense of just commuting and doing these things already takes so much energy out of you that you don't do. But nobody in the physics department. Mathematics department, yes.
Mm.
Mathematics department, we had Professor Huzur Bazar, who was a
Mm-hmm.
very, very inspiring teacher. He introduced us to completely outside the syllabus to modern methods of algebra, like algebras, groups, various things, and which were not in the syllabus at all. But he taught us all kinds of things, which was very good. But there was, except for Professor Huzur Bazar, there was nobody in the institute who was inspiring. But then it was compensated thousandfold more by the people in the Tata Institute who took so much interest
Mm.
in the young people. I think that was really. By the way, I mean, I later in my life I did contact Professor Yashpal and Professor Udgaonkar again, and it have been very, very nice and very good. I mean, for example, when Ayuka was about to be started, uh, the Professor Yashpal was chairman of UGC, and I wrote to him why I thought Pune would be a good place for it, and because I had actually visited, I discovered what is called Ashtekar variables or new variables by them for general relativity, and I visited Pune mathematics department because they had asked me, uh, and so I wrote to him about this, and so we had very nice contact. So I tried to pay back as much as possible, and for the same reason, I invested a lot of time and energy into Ayuka because it's really giving back. Professor Yashpal and Udgaonkar had done for me, and that was really giving back to them.
Yeah. By the way, I follow Professor Narlikar's blog, and currently he's writing these series of articles about how Ayuka formed. So he's already published around 6 articles. So currently he's writing the entire story in parts. So
Very
I'm
nice.
reading those. It's very
Yeah,
interesting
yeah.
and
And we used to
fascinating,
say that he had
actually.
these two lieutenants. And they are very, very different personality. Professor Naresh Dadich and Ajit Kembavi. They started out in this little house on the campus, which is called Gore Bangla. They
Mhm.
started in that little thing.
Looking back at your undergraduate years, what advice would you give to students who are currently doing that BSc degree? And if they have interest to pursue research, especially in theoretical physics? What kind of advices would you like to give them? One of the major area that I want to focus is the traits and qualities that make a researcher and make someone capable to contribute significantly in a field.
I think in some ways, life for students has become much simpler now because we got internet and there's access and you can look at YouTube videos and learn things much faster
Yeah.
than having to scrounge to bookstores and try to find the appropriate book, and which, I mean, the typical town bookstore
Mm,
would not have those books and so on and so forth. On the other hand, it's for the same reason. It's always like that in life, namely, one's strongest point is often one's weakest point, I think. So
mm,
it's also that this internet, etc., makes life very difficult for them because there is incredible amount of junk there. And so, to
mm,
me, strong advice would be to really find reliable blogs or reliable YouTube videos, and not just
mm.
sensational ones. I mean, because the ones which have many hits are typically sensational ones. They are not necessarily reliable ones. And so that, I think, is difficult. And so I would say that
Mm,
it's not just students, but also their mentors. That if the mentors could find for students the
mm,
reliable YouTube videos or blogs where contemporary issues in science are discussed, uh,
mm,
that is something that mentors could do, and the students could also make an effort and not just rely on, oh, this one has so many clicks or so many things. I mean, so
mm.
I think that there's a treasure that is available there, but that treasure is really
Yeah.
completely covered with a lot of junk, right? A lot of dust.
Uh,
So they have to find the appropriate thing, and there is a little work to be done. The second thing is that I mentioned is that, I mean, this is like this bicycle business, right? I mean, don't dive
mm,
into this pure science at the cost of not paying attention to your college curriculum or your regular
mm,
syllabus, your exam, etc. Because there's only one life, and in that life, unless you have a success of certain degree in the eyes of the world, you don't you don't even go further. So you had to do sufficiently well. That's what I meant by saying this balance of this bicycle. You have to do sufficiently well in the gauges by which you are judged. The
mm,
exams, whatever it is, your doors are kept open. I know
mm,
people who say, "Oh, I'm really interested in fundamental science and I did all this work, but then I can't get a degree, and therefore I'm thrown out of this thing." These things happen, and the point is that you have to strike this balance, and so don't neglect one thing completely in favor of the other. But in some
mm.
ways, later in life, that is a quality that is going to serve you most, which is really always striking this balance, because there are always going to be choices,
Yeah.
particularly choices between practicalities in order to survive in their practicalities and what your heart really beats. And you have
Mm,
to balance these two things together. So they should sort of follow these new things very much, but not at the cost of neglecting their regular work, even though they might find it boring. They have to do sufficiently well. And then the other thing is that when they do find these YouTube videos or something, they should use them in order to get a, a feel, in order to understand qualitatively what is happening, what are the frontiers of science, etc., etc. But know really deep down that this is the first step. There's a
mm,
huge on which you have to build a whole building. This is just the first step that you are climbed up here. So
mm,
unless you can do things which are detailed, right? I mean, don't say I mean, I get all this message all the time. I got this theory of the universe, right? Because it's something. I mean, no, I mean,
mm,
theory of the universe is not built in one day like that. You need to have your sharp tools, and therefore
mm,
I think that it's extremely important to also carry the toolbox with you and to develop it, especially at a younger
mm,
age, to develop it. And it's not only
mhm,
undergraduates, but also particularly PhD students and so on and so forth. They often just
mm,
focus on their research. and that whatever the
mm,
topic that was given to you them by their advisor, and that is really bad because as time goes on, you have less and less time to broaden out, to learn things, because there are more and more demands on
mm,
your time. You have committee meetings, you have, you know, proposal to review, you have to, publication pressure. There's all kinds of things that teaching, all kind of things happen. When you're a student and a postdoc, that is a time to really acquire a lot of technical tools, to have this toolbox that then you'll be able to use somewhere, and
mm,
and
mm,
also broaden out, right? I mean, broaden out sufficiently. I mean, my PhD advisor, like next time we'll talk when you talk about um, my years in the United States as a student. Uh, he
mm,
he had a very 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 beautiful image. He said that for a good scientist, your knowledge should be like a Gaussian. In other words, it should have a
uh,
peak. Some area in which you really know a lot, but it should not be
mm,
like a sharply peak, like a delta distribution, which is just infinitely peak somewhere. It should also have breadth.
mm,
And again, because of one's abilities and one's total time that one has, you know, you cannot have all possible areas, so to say. Area is kind of the constraining factor. So somebody might say, well, I'm very, very broad and not very deep, so to say. That is not a good scientist. Or somebody can say, I'm very, very sharp and very, very narrow. That's not a good scientist either. So you have to have this peak, right? I mean, this Gaussian shape, something in which there are areas in which you know a lot, a lot, a lot. But then there are a lot of nearby areas that you know quite a bit, because your next work will likely not be where your peak is. Your next work will be in these other areas. And the number of people who spend their almost entire life doing research in the same narrow area in which
mm,
they got their PhD thesis is large. And
mm,
that, I think, is not very productive. I think you have to change. I mean, the extreme example of this, of course, is Professor S. Chandrasekhar, who changed his very area of
mm.
research every 10 years of his life. That I think very few people can do.
Yeah.
But on the other hand, having this Gaussian image of your knowledge is something that postdocs and students should keep in mind.
That's a very valuable advice, sir. Thank you, sir, so much for sharing your remarkable journey so far. And we'll continue this story and we'll have other
Yeah.
sessions where we can continue and explore your time in the US and
Yeah.
also later.
Take care. Bye
Thank you
bye.
so much. Thank you.